most mysterious navigational tool that birds use is their ability to sense the Earth's magnetic field, a phenomenon known as magnetoreception, which I've covered as it relates to humans in a separate video. The Earth generates a magnetic field that extends from its interior into space, with field lines that emanate from the poles and curve around the planet. This geomagnetic field provides a reliable reference for direction and can be used to determine both latitude and longitude, making it an invaluable tool for long-distance navigation. Birds possess a specialized sensory system that allows them to detect the Earth's magnetic field and use it for orientation. This capability is thought to involve two main mechanisms, one based on magnetite and the other on a light-dependent chemical reaction. The magnetite-based mechanism involves microscopic crystals of magnetite, a magnetic mineral, thus the name, located in the upper beak of some bird species. These magnetite crystals can respond to the Earth's magnetic field, providing birds with information about their position relative to the magnetic poles. The light-dependent mechanism is even more intriguing and involves specialized proteins in the bird's eyes called cryptochromes. Cryptochromes are sensitive to blue light and are believed to participate in a quantum reaction that's influenced by the magnetic field. This reaction may allow birds to see the magnetic field as a visual pattern or a map superimposed on their normal vision, providing directional information. This hypothesis, though not yet fully understood, suggests that birds can integrate magnetic cues with visual information, giving them a unique and sophisticated means of navigation. Magnetoreception is especially important during migration when birds need to maintain a consistent direction over long distances. But it's not their only navigational tool. Birds also rely heavily on visual landmarks and topographical features to find their way. During the day, birds can use prominent features such as rivers, coastlines, and mountain ranges to navigate. For example, waterfowl often follow river systems. Raptors may use mountain ranges as guiding lines. This type of navigation is called piloting, and it requires birds to recognize and remember specific landmarks along their migratory routes. In addition to physical landmarks, birds use celestial cues for navigation. Many nocturnal migrants, like songbirds, rely on the stars to orient themselves. Research has shown that birds can learn the position of constellations in the night sky relative to the North Star Polaris, which remains relatively fixed in the northern hemisphere sky. By aligning themselves with the stars, birds can maintain a consistent migratory direction even when flying at night. This ability to use star patterns is not innate but learned. Young birds need to observe the night sky to develop their celestial compass. The sun also plays a critical role in avian navigation. Birds use the position of the sun in the sky to determine direction, a process known as solar compass orientation. As the sun moves across the sky during the day, its position changes, and birds need to compensate for this movement by using their internal circadian clocks. These internal clocks allow birds to keep track of time and adjust their orientation relative to the sun's position. For example, if a bird knows that it's morning and the sun is in the east, it can fly south by keeping the sun to its left. This sun compass is remarkably precise and enables birds to navigate accurately even when the landscape below is unfamiliar to them. switch between different cues depending on the circumstances. For example, on a clear day, a bird might use the sun and landmarks to navigate. If clouds obscure the sun, it might switch to using its magnetic compass. And if flying at night, it might use the stars. This flexibility in using multiple navigation systems ensures that birds can find their way, even when one or more cues are unavailable to them. But this intricate system is not without its challenges. Human activities have significantly altered the landscapes and environments that birds rely on for navigation. One of the most pressing issues is light pollution, which affects birds' ability to use natural light cues such as the stars and the moon. Artificial lights from cities and towns create a bright glow that obscures the night sky, making it difficult for birds to see and use celestial cues. This can lead to disorientation and even cause birds to fly in circles or crash into buildings. Migratory birds are especially vulnerable during overcast nights when they're already relying heavily on their star compass and becoming disoriented by bright city lights. Another major challenge is habitat fragmentation and the creation of artificial landscapes. Urbanization, agriculture, and infrastructure development have dramatically changed the natural habitats that birds use for navigation. For instance, large-scale deforestation removes important forest corridors that many species rely on during migration. Similarly, the construction of wind farms and communication towers poses physical hazards to flying birds, leading to collisions and fatalities. Artificial landscapes can also confuse birds by creating misleading visual cues. For example, large bodies of water, such as reservoirs or artificial lakes, may look similar to natural lakes and rivers that birds use as navigational aids. But these artificial features may not lead to suitable habitats or resources, causing birds to waste valuable energy and time. Similarly, roads and highways can mimic natural linear features such as rivers, leading birds off course. In addition to these physical changes, climate change is altering the timing and availability of resources along migratory routes. Shifts in temperature and weather patterns can affect the availability of food and stopover sites, which are absolutely crucial for refueling during migration. Birds that rely on specific environmental cues audible and visual